Welcome students. We were doing chapter 2 inverse trigonometric functions. Today we will discuss the properties of inverse trigonometric functions. Some results may not be valid for all values of domain of inverse trigonometric functions. In fact, they will be valid for some values of x for which inverse trigonometric functions are defined. We will not go into details because it is beyond of your syllabus. First, I want to tell you if y equal to sine x, so this implies we can write sine inverse y equal to x, or x equal to sine y, then sine inverse x equal to y. अगर y इक्वल टू साइन एक्स है तो हम इसको जब साइन इधर इसको हम क्या लिख सकते हैं, साइन इनवर्स y इक्वल टू एक्स, टेकिंग साइन इनवर्स ऑफ बोथ द साइड्स. साइन इनवर्स y इक्वल टू साइन इनवर्स ऑफ साइन x इक्वल टू x. सेम हियर, x इक्वल टू साइन y, टेकिंग साइन इनवर्स ऑफ बोथ द साइड, तो साइन इनवर्स x इज इक्वल टू साइन इनवर्स ऑफ साइन y इक्वल टू y. क्लियर? इन चीजों को ध्यान रखें. In this part there are three properties. First, sine inverse 1 upon x is equal to cosec inverse x when x is greater than or equal to 1 and x less than or equal to minus 1. Second, cos inverse 1 upon x is equal to sec inverse x when x is greater than or equal to 1 and x is less than or equal to minus 1. Third, tan inverse 1 upon x is equal to cot inverse x when x greater than 0. 1. I am proving for you. I am proving sine inverse 1 upon x is equal to cosec inverse x. Let cosec inverse x is equal to y. Therefore, x equal to cosec y. Clear? Now, 1 upon x equal to 1 upon cosec y. Therefore, 1 upon x equal to sin y, or therefore y equal to sin inverse 1 upon x. In place of y we can write cosec inverse x. Clear? Similarly you can prove other two properties. Now next, first one, sine inverse of minus x is equal to minus sine inverse x when x belongs to closed interval minus 1 and plus 1. Second, tan inverse of minus x is equal to minus tan inverse x when x belongs to R. Third, cosec inverse of minus x is equal to minus cosec inverse x when mod x is greater than or equal to 1. First part, let sine inverse of minus x is equal to y, so this implies minus x equal to sin y, or this implies x equal to minus sin y, or you can write here sin of minus y, sin of minus y minus sin y, and therefore minus y is equal to sin inverse x, and this implies y equal to minus sin inverse x. In place of y we can write sin inverse of minus x. In this way, Sine inverse of minus x equal to minus sine inverse x. Other two parts you can prove yourself. Now third. First, cos inverse of minus x is equal to pi minus cos inverse x. Second, sec inverse of minus x is equal to pi minus sec inverse x. And third one is cot inverse of minus x equal to pi minus cot inverse x. This one is valid when x belongs to closed interval minus 1, 1, and this one is valid when mod x is greater than or equal to 1, and this one is valid when x belongs to R. First part, proof. Let cos inverse of minus x equal to y, so this implies minus x equal to cos y and x is equal to minus cos y, or you can write x equal to cos pi minus y. Since cos pi minus theta equal to minus cos theta, therefore minus cos y can be written as cos pi minus y. And this implies pi minus y is equal to cos inverse x. And cos inverse you can write here pi minus cos inverse x equal to y. Then in place of y we can write cos inverse of, so pi minus cos inverse x is equal to cos inverse of minus x. Clearly, similarly you can prove other two parts. Now next one. D. Sine inverse of x plus cos inverse of x is equal to pi by 2 when x belongs to closed interval minus 1, 1. Second, tan inverse x plus cot inverse x is equal to pi by 2 when x belongs to R. Third, sec inverse x plus cosec inverse x is equal to pi by 2 when x mod x greater than or equal to 1. Clear? First part, इसका मैं प्रूफ कर देता हूं. Let sine inverse x is equal to y, so this implies x equal to sin y, or x equal to can be written as cos pi by 2 minus y, since cos pi by 2 minus theta sin theta, or this implies cos inverse x is equal to pi by 2 minus y. Clear? Now then cos inverse x plus y is equal to pi by 2. In place of y we can write sin inverse x. So cos inverse x plus sin inverse x equal to pi by 2. Is that clear? No. Other parts you can do yourself. Now E. The first property, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy when xy less than 1. Second, tan inverse x plus tan inverse y pi plus tan inverse x plus y when upon 1 minus xy when xy greater than 1. And third one, tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy when xy greater than equal to minus 1. तो फर्स्ट का मैं प्रूव कर रहा हूं. प्रूफ let tan inverse x equal to theta and tan inverse y equal to phi. So this implies x equal to tan theta and y equal to tan phi. Now tan theta plus phi, you know tan a plus b, tan a plus tan b upon 1 minus tan a tan b. In place of tan theta we can write here x, and in place of tan phi y, 1 minus xy. Now theta plus phi will be tan inverse x plus y upon 1 minus xy. Now put in place of theta tan inverse x and in place of y tan inverse y, then tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Clear? Now some other properties. First, 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. Second, when mod of x is less than equal to 1, and 2 tan inverse x equal to cos inverse 1 minus x square upon 1 plus x square when x is greater than equal to 0. And third, 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square when x lying between minus 1 and 1. Clear? तो फर्स्ट का मैं प्रूव कर देता हूं, आगे दो अपना आप करेंगे. Proof. Let tan inverse x is equal to, हमने tan inverse x को y let कर लिया. This implies x equal to tan y. Clear? Now this one, sin inverse 2x upon 1 plus x square. In place of x we can write tan y 1 plus tan square y. This is the formula of sin 2 theta. Sin 2 theta 2 tan theta upon 1 plus tan square theta. Therefore we can write in place of this, what we can write here, sin 2 theta, sin 2y. Clear? Now sin inverse of sin x, it means 2y, or in place of y we can write tan inverse x. Proved? So sin inverse 2x upon 1 plus x square equal to 2 tan inverse x. Similarly we can prove other two properties in this way. All properties are finished. Clear? Which are in your syllabus. In next video we will take exercise based on these properties. Okay, thank you very much.